So first of all, thank you for giving me the opportunity to introduce you today in the topic of data management for SDV. It's a great pleasure to be here, and I hope you will enjoy the presentation as well. You can give feedback afterwards if you like. First, my name is Hans-Dirk. I'm quite sure that not everybody of you will know me. I studied computer science. I worked for more than 20 years as a software developer until my teammates obviously assumed that I'm easy to replace as coder and asked me to do the management tasks in the company. And the company we are working for is called Karakoon as well. I don't believe that you, or most of them, have ever heard of this company. Although we as a team exist more than 23 years. And here you see the crowd. And one specialty is most of the guys here own the company. So the company is owned by us, by the team. And we are a classical software development company, mostly engaged in custom solutions. And we have a strong area in the digital engineering solutions. I'm personally responsible for this area. And the third thing, which is NLP and AI-based text analysis. One of the most common use cases is search, but there are a lot of other use cases, especially in the data protection area. And we are also very proud of being part of the open source community for more than 23 years. We started in 2000, which framework for testing HTML generating web applications. It was web-based. We did a lot of things afterwards. And our last product is Java OpenWebStart, which replaces the commercial version from Java WebStart from Oracle. And I think we have about 300 to 400,000 active users worldwide for this open source tool. And in the automotive area, we are members of the Eclipse working group OpenMDM. And we are also a member of this working group, SDV. But I have to admit, we are looking a little bit for our role in this community. And that's the reason I wanted to introduce this special topic as well, as a data management. And as a side remark, we are also engaged in the involvement of agile development since 2000. We are a little bit proud that we can call ourselves a kind of pioneers in this area, because in the first presentation, agile development was also mentioned, and the development methods shall be topic of this work group as well. Maybe that could be a contribution as well. So why data management for SDV? Why do we consider that this is a crucial topic for this community? Of course, tons of data will be generated in the vehicle during development, during simulation, testing, and of course also during operation. And those data have to be somehow managed, especially if you consider that you want at some time validate, certificate what you have developed. So all what you do has to be traceable and best standardized, that you are not dependent on any technology, and yet you can speak to each other. And of course, it would be also wishful to have to build on non-vendor specific technology. And why are we especially presenting this to you? Because we are working since 10 years in this area of test data management, and are also, besides this open source community, engaged in some of the standardization organizations like ASAM and the PROSEP IWIP. So I hijacked an older version of the fleet management use case, which has already been introduced in a former talk, and just quite brutally put in where I might consider the place for OpenMDM. Of course, it's the data management, the time series management. Don't take this too literal. Of course, it's not really in architecture and really about little interfaces. It should just tell you we are speaking of an off-vehicle data management solution, which can maybe a good starting point for the data management in the SDV community for whatever use case might come up in the future or might be also be there. So, yeah, as OpenMDM, that's the goal of my talk here today, is to convince you that OpenMDM is a good candidate as a starting point for the off-vehicle data management. So what is OpenMDM? Sarah already mentioned it. It's actually a working group like SDV. There are some differences. The first difference is we are fewer members. It's a quite familiar environment. And of course, any new members are really welcome. We are quite old. Next year, we will celebrate our 10 years anniversary. And the topic was always standardized test measurement, simulation, result data management. There's also, as usual, an Eclipse project, and this working group actually really is focused on one special Eclipse project, that is the MDMBL. To be not confused, I will always speak about OpenMDM, both speaking about the working group and the software. I will not distinguish because historically, nobody in the community speaks about MDMBL already. Everybody is speaking about OpenMDM. And you also see the URLs on the slide. Feel free to visit them. So next point. What is special? What is special with OpenMDM? And we as a company, Karakun, we are contributing to OpenMDM. We have also built a product on OpenMDM. And therefore, especially for us, there was one special feature that is that engineers can create very specific models for components, for test environments, for whatever you can conceive. And all this can be living together in one database. And it's quite flexible to extend. You don't need a big project. It's actually programmable at one time to extend your models. I will explain it later a little bit in more depth. And the second very crucial feature is that it is very tightly integrated. It very tightly integrates metadata management and mass data management. So the first thing I will explain by giving you more insight into the data model, maybe a kind of tough section before the lunch. And the second one, hopefully it will work, by a live demo. But first, to set the scope for OpenMDM, I would give you a kind of overview what you will find in the Eclipse repository and the GitHub. It's first the main part is the MDMBL. It is a backend software layer which an HTTP REST API, which connects with some various adapters to an underlying database server, which is currently very dependent on the ISAM ODS standard. But as you can see here in the right, there are already adapters, or one adapter at least, that is, two adapters that use different databases. Of course, the data model of the database server must be quite close to the ODS standard. You will see it later when I go into the model, why it's obviously the reason. So, and this backend layer, this server is the main part of the repository. We also have an explorer, a UI, an application that can be used immediately, where you can browse around in your data. I will show it later. Yeah, you will see it later. We consider it more an example application, but it's a good way to get into the project and to immediately start with visiting your data. So now, oh, sorry, I have to go back for one slide. Currently, the only way to get data into OpenMDM is by means of files. That is the current standard way. You have some data file which you want to manage, and yet you include it or import it into the data server. Of course, conceptually, there would be, as I see, no hurdle or no blocker also to use over-the-air import protocols like MQTT or something else. Of course, depends on the workload and on the amount of data you want to transfer. So let's start the OpenM data model. So as you can see here, I think you don't need lunch. So I will go through, no, don't worry, I will not go through all these things. This is only to impress you a little bit how many entities already have been defined in this model. And this is one of the things. You can add new things as well. Of course, they are not necessarily part of the standard, also not necessarily part of the ODS stuff, but at least it's extensible. So that is the current state of the model. And I have simplified it a little bit that you get a first impression how this is working. So you see here 3 hierarchies, more or less. And all is beyond the central concept, the test. Test is very wide term in this case. And if you take the upper road, you come to the unit under test. It's exactly what you are considering, which is again a hierarchy. In the middle, there's a test configuration. You can structure your test in test steps, but you can define a configuration of your real test by combining various test steps. I will give an example later. And the lower path, it describes the equipment you are using with sensors as a first-class citizen in the model. And beyond the test step, there is one box which is measurement. It is in the model quite more complex. You will see more in the demo, but here it contains the real result data. All these entities contain predefined attributes with predefined data types that are defined. That the semantics of these data types are defined. So this is not flexible, but the semantics with the defined semantics, which is quite valuable if you want to exchange things between various programs. But this is, of course, limiting. You want to extend your model with your own attributes that you want to use for your use case. And therefore, you see the same hierarchies with the TPL before, which means template. And for every template entity, you can add specific attributes that you need. So for instance, I took an example from the autonomous driving. The unit under test might be a special truck model with your attributes, your data inside, which are not part of the predefined stuff I showed before. Then your test could be maybe the maneuver passing by, which some tests have switch lane, and beyond a configuration of steps. You might have several scenarios where you might cancel a passing by maneuver or have not switch back lane or whatever. So this is the means for configure your tests. Then the test equipment, your instrumentation, what you are using to record your data. And maybe as a sensor, a special LiDAR. And this LiDAR might have own attributes which are not part of the generic specific model. And here in the measurement, numerous of channel groups, these channels can be stored that really contain all your data of various types: audio, video, temperature, pressure, acceleration, whatever you are measuring. And as I said, the tables on the right, they contain the user-defined attributes, the attributes you are defining for your application. And when it comes to real execution, then you have to create such kind of objects. For instance, a concrete maneuver with a concrete LiDAR, which took place today. And this object contains both the generic and the specific data. So what has been predefined and all the special attributes we wanted to add to make a unit under test a truck. And the real valuable capability of OpenMDM is that all these things are traceable. If you change your model, you can always be sure that your created data match to the state of the model at this time this data were created. So all is version control and is history control. So you can really have, if you have at one state a measurement where some attributes are missing, this is accordingly stored in the database. You will have no inconsistent data. And you can always trace down what you have changed and what configuration have been used for what test. So this was the data modeling capabilities. And now cross our fingers that things will work. I will come to the second part. That's the integration of mass and measurement data. Yeah, I think it's large enough. So first, this is the application, the UI, which is already contained in the repository. So if you check out the stuff, you have this UI as well. There are authentication, authorization, so all the data are access controlled. So you have security inside. Looks like that there's some connection. Yeah, that is the risk you always take if you try such things. Looks like that the internet connection is not there. Second point is, oh, VPN is still there. So I will just give it a second try. Otherwise, then I will go to my plan B, which is maybe then. So it's now I have to. Yeah, it looks like the internet connection is somehow broken. Okay, let's don't lose time. Then I will go for the alternative. That is, yes, going. Okay. Start with this one here. Okay. Okay, then sorry about this. I will try. If you like, I can try. I can try it later. It is obviously an internet connection problem that I face. So now you will have this demo as a PowerPoint slideshow, but I hope this will get a little bit of impression. As I said, you have authorization, authentication implemented. So if you start up, then you get the first the screen where you have the usual search capabilities, full text search and structured search. And I will point your attention to the left table tree there, the tree which we are seeing there. That reflects more or less the structure you have seen. So you have seen before, which means that is the test step, test step, and you see there three measurements. By the way, the data set which I use is a published data set for autonomous driving, which has been published by Audi a few years ago. I think it was 2020 or something like this. And there's another data set about kart racing, maybe if the Ross racing scenario is use case is relevant, might be it's interesting stuff as well. But I will focus on this autonomous driving thing. So you see the structure, test step, and the three measurements. And if you select one of these measurements, you will get a detail page with the metadata. And these metadata, here were those which have been provided by Audi for the test data. Of course, you can do a lot more if you like. Here you see what car was be tested. So that is the information about the unit under test, in this case a Q7. And this is the instrumentation, the equipment they have used. For instance, a certain LiDAR was used here, which can also be queried. So, as you can see, there are a lot of information about what kind of equipment were used in these cars, which I think have been driven around in the area of Ingolstadt. Now, the results, as you can see here, are grouped beyond the measurement in channel groups. All these things are channel groups which consist of various channels. So there are some channels already here, but there are scenarios with about 20,000 or more channels which can be managed. Of course, that was remarked before. I think if people are very engaged in user experience, there might be some leeway for improvement with this application. So now it comes the real cool thing. You can also have a kind of access to the mass data. And in this case, it's implemented in an XY chart. And we select this XY chart. And we select one channel group in this case and two channels. And if you would see the real demo here, I now would have the challenge to spend some time until the results are shown, because normally we have not a big cluster behind. This takes a while because the real mass data are accessed. So this function really goes to the channel data. And I think in one of the first presentation, this environment runs both on public clouds or clouds of the hyperscaler, but we have already used it in the HPC of an OEM. So it's not dependent where you are. It's containerizable, and that is a use case which used an internal HPC. So as I said, the channel group and the channels, and now it's immediately there, but that's the magic of PowerPoint, not of our software. Normally, this would have taken a while, and this is data produced by accessing the mass data. So so far the live demo. Sorry about this. As I said, come to me and we can repeat this maybe in the afternoon or some other place. So OpenMDM is live and in production. There are NVH test applications at various organizations running. There's CREST test applications in various organizations running. There's QA applications for e-engines in production. There's one product I was able to show the screen for this because it's our product. It's a parameter database or function data management tool. The terminology is not standardized. And there's also a big data analytics environment available, which runs also on any cloud or HPC. And some advertisement. This tool is called Exonox and is using OpenMDM inside. So that was the contents. Now the summary, why OpenMDM for off-car data management? I think the last point is one of the most important. It exists, it is proven in production at various organizations, is software which can be used. And the other things is, as I said, it supports traceability of model changes into cell data history, and the engineers are able to adapt the models according to the application or use cases they want to implement. And it's open source and based on a standard with all the advantages and disadvantages. I will not hide for you, it also has some disadvantages. I will not go into detail about this, but it is, of course, I think for most of you, not the problem, but it is it's also not only advantages. So, and if you want to test installation, you can just approach me. That's all.
So maybe I do have one. Those data, so do they come from Catena X, for instance, or?
Up to now, not. Most of them are generated on test benches.
Okay.
Or in cars, the bus data usually. It's far as I know, the issue is it's open source and we are a community of various companies. I'm not aware of all use cases. I just mentioned those I know of. So I would 100% don't know, but I don't know of any use case where Catena X really was integrated into this.
One more question. What about the labeling? So the labeling is an input, or have you thought about have you thought about labeling inside the tool or
labeling
to a standard one?
Labeling of data.
Obvious cases such as, I don't know, passing, so a truck passing a car. That would be, I don't know.
I would say that if you have a standardized or somehow predefined labeling, then you have to analyze whether it's in the fixed part already available, because there are a lot of attributes which of course might contain label. If not, you have to add it, but then you can use it.
Yeah.
It's a metadata.
Sure, absolutely.
And you can use or define any metadata you want. You can label all the entities in the hierarchy as you like. But I know not by heart what exactly is in the core, whether there's already something which is called label or which can be used as a label field. But it would be easy to extend. And as I said, it's the model. Even the base model can be changed. Yeah. So that would be no problem.
So, question. I'll get it.
Thank you. I'm Arndt from ITAS in Stuttgart. What I've seen, it's not a technical question on your presentation. It's a general general question. There were very few questions. Now, I'm the project lead of another project in Germany, the Soft DCAR project. And what I've seen there is that most of us are working in just one area. And when there is a tool that is being presented, then people say, well, interesting, but I don't use that because I'm struggling with this. I do some unit tests and I try to kind of fiddle a little bit with it and get it up to working. My little thing, you know, my 5% of the whole thing. And I'm, as a project manager, then always try to say, what is the global picture? What do you need? How can you build this software-defined vehicle? I always challenge people then and say, do you have your software-defined vehicle in your courtyard? And you as a developer, we are developing kind of the tools, and so but the OEM or the tier one, he should have a car sitting there, or a virtual car if we want to do a simulation, but the car, and the developer himself, he should say, how long does it take for me if I commit code that I can see it in the, down there, I can see it. Is it 1 hour? Is it a week? Is it a month? Do I have to call 10 people to test, to download? Is the release train broken, and so on? And so this is kind of to span this general question. Do we in SDV think about this global approach that we have a car and we want that, or a truck, whatever, a vehicle, that we want to, you know, to provide everything so that it, you know, that it works, that it drives. And the code I write is within minutes, committed, has gone through many tests like here, and so on. So this is kind of why maybe there are no questions, because each one is working on his small component. Comments? I don't know. Thank you.
Yeah, but it would be good if the comment came from you. But I completely understand your comment here. And I, as the program manager of this whole thing, I absolutely feel what you're saying. And yes, so the working group started historically with projects addressing a very special case, the digital twin or so on, which is great, absolutely useful. But the question and what we need to address, if not in this community day, in the coming ones, is where do we want our working group to go? Because we have seen that we get projects that are more about the tooling environment, which is great. But on the other hand, as you said, everyone works in his own little garden and cares little about the whole DevOps chain, for instance. And this is where we need to start shifting our attention and shifting the way that we see the working group, because it's perfectly fine if we say the SDV working groups focuses on the middleware. We are a middleware working group, and this is what we do. This is an answer. But seeing the project that we receive, it looks like we want to be much more. We have a much more ambitious view where we want to also provide the tool and the tool chain to the developers so that they can actually develop faster and also develop the tools in the open. And this is an open question in my point of view. So based on the project we receive, we are going in this direction. But then again, are they really going to be used? This is a good question. And this is a question that only the community and the adoption can answer. Anyone wants to comment? I mean, any developer would think tomorrow of trying out OpenMDM as database, or OpenXL as a measurement framework environment, or eCal to test and visualize and use this API to Foxglove. So does any of you, based on what you have seen today so far, would you change anything in your development? So that's a question that I'm posing to you, and I would really like anyone to comment on this. Yeah.
Hi, here's Marco from the Linux Foundation project Everest, so not Eclipse, where we're doing EV charger firmware, and we're using currently MQTT as middleware, and we have some downsides with that, and I really like what eCal presented. Performance is not on the today's to-do list, but probably for early next year. So yes, that was an interesting presentation, and we will connect.
Okay. Very good. So any other development that tomorrow would think about going to their project manager and say, I don't want to use your old application. I want to use some open source tool that I saw today. Anyone that would think about doing this? Yep. Peter?
Thank you very much. Peter from AVL again. So two things first, actually three. So yes, I do think I got a few ideas already in this morning about going to the management and asking for connecting to something. But for me, probably this question, which was originally posed of do we get the full picture? I was hoping that the blueprints address this more and more, that they try out the complete application, ideally a complete value chain at some point, and bring together the whole thing. And then, of course, it's a dogfood thing. So we should, of course, use our own tools, our own modules, our own stuff to see how it works in a more complete picture. And the third comment is more towards the OpenMDM. I would have a specific question regarding if we do use that for ADAS testing, I would have hoped that we also see things like the other actors and the scenes. So I didn't see this in the data model. Other actors and the scenarios and so on. So I guess this will be extensions coming, right?
So to answer this question, so there have been ideas in the past to use the measurement, the result data to store also model information. So these scenarios, and so I personally, it's my personal opinion, not the community opinion. I don't like this approach to misuse things which have been developed for other things. So this is really a result data container. And the equipment description you need is not, I think it's not the same as a model of your scenarios, as a model of your things. So there are, I mentioned ASM, there are the open scenario, open ODD and whatever things. I don't think that those things you are implementing there, they are only domains languages they are developed, are really one-to-one mappable to this. But when you really execute things, then I think this come into place. And the question around how to handle the models, I understood your question in this direction. How you handle the models of your scenarios of autonomous driving. I think it's for me it's open, this question. I have no answer today. We can try to evolve OpenMDM into this direction. But I'm not really sure whether this is the best or the only solution conceivable. But what you currently have, if you have a simulation system, if you have models and you do execute something and you, for instance, simulate your bus and generate a lot of bus data, then you can use this stuff to store them traceable. And I think that is the value which is generated today. And all the other things we have to discuss.
Yep. Thanks.
Over time.
I have a question also and a general comment also. So the question is that I saw that you are plotting some data. Is that data sources coming from ASM open standard MDF file format, or can I use some custom data source plugin as well?
That's a very good question. You are not the first you asked this. I have we had already discussion in another context. Currently, it's only ODS-based data and the big data, or in the classical ODS format, and there's a big data ODS format which allows to use Parquet and Avro files. Okay. It is the last ODS release supported and created an extended API which allows to integrate MDF4 files. That was the main goal, but is open to other things. So currently, yes, I think, as I said, there are two adopters or users of OpenMDM, which I know who I know of, who are already using OpenMDM on top of data stores which are not ASAM ODS. So one is as far as I know, an OEM who has implemented this, and the other is more in the acoustic area, and they have an own system which is somehow ODS but not really ODS. So it is possible, but you have seen this data model. And if you want to map this data model to something which has far less semantics, then it will create a problem. So this is I think there is a boundary of freedom you have.
So I asked this question because I have my also colleague from Continental, because I'm also from Conti. And of course, I'm also the user of eCal measurement. So the thing is that this.
So then it's the same context.
Data management topic with the eCal, also an open source measurement data, the bridge to connect these two things is missing. Then do we have such plan to integrate this kind of measurement file format, which is also coming from open source community now, to integrate them?
We can create a plan.
Yeah, so I would say we can move this over to lunch because we already are quite late.
So I would be very interested to follow this up.
Last question, please, if possible. So how does this help the data-driven development approach, this data management whole? Do we have such thing in mind or not? Because when we talk about the autonomous driving, we are talking about petabytes of data.
Yes.
Analyze and to search.
I have something in mind, but I fear that it's not explainable in 1 minute. So actually, I mentioned this this Exonox, this tool, which is not managing result data. It is managing input data for simulations, function data, which define, and this is the whole scenario is intended for data-driven engineering. So we have something which you use, data you use to feed your simulation models, for instance. You do something, you test something, you let something run, and then you have the result data. Use the knowledge you gain, the lessons you learn, and optimize your results. That is the scenario we are currently working in. Yes. But it's not covered, of course, by OpenMDM and those things. That is just really result data. I think someone mentioned something which should be close and have a certain goal, and I think this is currently the vision of these things. But yes, in this case, in this sense, it is contribution to data-driven engineering.
Thank you. Thank you.